Hi guys, this is Kamal. Today here we are going to discussing about input output management in operating system. Introduction. The things which we are going to learn few more minutes in this video are introduction to management in operating system, memory management, process management, device management, file management. Input output management in operating system. Effective input output management is crucial for any operating system to function smoothly. Let's dive into different techniques used to manage memory processes, devices, files, and security. Introduction to management in operating system. Overview. Operating systems are designed to manage a computer's hardware, resource, and facilitate communication between various software components. The input-output system is an integral part of any modern operating system and comprises diverse management techniques. Purpose. The purpose of input-output management is to manage the transfer of data between the CPU and the computer's hardware peripherals, input and output devices, ensuring the efficient use of system resources and providing a positive user experience. Challenges. Some of the critical challenges in input output management include latency, throughput, and buffer overflow. Memory management. Memory allocation. Memory management refers to the allocation and deallocation of main memory. It is essential to optimize memory usage and avoid overloading the system. Several techniques such as paging, segmentation, and virtual memory are used. Secondary storage. Secondary storage provides additional memory to supply the system's primary memory. Technique like caching and buffering are used to improve performing when using secondary storage device. Memory management units. A memory management unit is a hardware component that handles the virtual to physical memory translation and helps the system manage memory effectively. Process management. The first thing is process scheduling. Process scheduling determines which process should run when using the system's CPU. Different techniques such as round robin scheduling, priority scheduling, and shortest job first scheduling are used. And the second thing is Intel process communication. IPC. Intel process communication involves coordination communication between processes. Communication channels such as shared memory, message queues, and pipes are implemented to facilitate intel inter-process communication. And the third one is process states. The state of a process determines what the system is currently doing with it. Typically, processes states include ready, running, wait, and terminated. Device management. Device drive. A device drive serves as a mediator between the device hardware and the software using it. Supports communication between the two, translating software instruction into hardware commands. Second one, device queues. Device queues providing a way to manage tasks sent to the device hardware. They allow scheduling of device CPU access and keep track of the device status. Interrupts. Interrupts are signals sent to the CPU by the hardware. They prompt the CPU to stop the current task and switch to higher priority tasks such as responding to the interrupt. Device controllers. Device controllers are hardware components responsible for managing input-output operating operations with specific devices. They transfer data between the device and memory and coordinate with the CPU for further processing. File management. First, in file management, the first one is create, open, and close. File operations including create new files, opening existing ones, and closing them. The file control block (FCB) data structure stores metadata about the file, including ownership, access permissions, and location on disk. The second one is access and permission. Access controls and permissions restrict access to files and protect them from unauthorized modification or deletion. Techniques such as encryption and backups are also used to ensure data securely and recovery. File system structure. The file system structure determines how files are organized and stored on the storage device. Different file systems types such as FAT, NTFS, and ext4 exist for different operating systems and devices. File management. Authentication. Authentication is the process of verifying users' identification and ensuring they are authorized to access system resources. Username and password, biometric identification, two-factor authentication. Access control. Access control determines which resource users can access the restricts authorized access. Role-based access control, mandatory access control, discretionary access control. Firewall protection. A firewall limits the incoming and outgoing traffic of a network, preventing unauthorized network access and attacks from malware or hackers. Network address translation, packet filtering, and proxy server. Virtual memory. An application or file may be too big to fit into the available RAM. This is when virtual memory is used. Secondary storage, that is hard disk, is used to store code or files that would normally be held in the RAM. The operating system will then treat that part of secondary storage as if it was part of the RAM. Tagging. The kernel or central block main part of the code is held in the RAM. The rest of the code, also known as pages, are loaded from the secondary storage when needed. This method allows large applications to run in a small section of the RAM. This can also then free up memory for other applications to use. The three major jobs of computer are input, output, and processing. In a lot of cases, the most important job is input or output, and the processing is simply incidental. For example, when you browse a web page or edit any file, our immediate attention is to read or enter some information, not for computing an answer. The primary role of the operating system in computer input-output is to manage and organize input-output operations. And all input-output devices in this chapter you will learn about the various uses of input-output devices, con- concreting the operating system. The controlling of various devices that are connected to the computer is a key concern of operating systems designers. This is because input-output devices vary so widely in their functionality and spread. For example, a mouse, a hard disk, and a CD-ROM. Varied methods are required for controlling them. These methods from the input-output subsystem of kernel of the operating system that separates the rest of the kernel from the complications of managing input-output devices and input-output hardware.